Somewhere about 65 million light-years away floats a galaxy that, by the laws of physics we trust, should not be able to hold itself together. Every other galaxy in the universe is glued together by a vast, invisible something we can't see, can't touch, and still can't identify. This one is missing it. It is a galaxy running without the single ingredient we thought every galaxy needed just to exist. And here's the twist that flipped astronomy on its head. This impossible galaxy might be the strongest proof, yet that the invisible glue is actually real. Losing it accidentally revealed it. So today we're chasing a ghost. We'll cover why every galaxy needs an invisible scaffold just to survive, how a team of astronomers found the one galaxy that somehow skipped it, why that single discovery started a genuine scientific brawl, and the wild origin story that explains how you even build a galaxy with its skeleton ripped out. Stick around, because by the end, the galaxy that shouldn't exist becomes the best evidence we have that the rest of the universe is stranger than it looks. Start with a problem astronomers have been sweating over for almost a century. Galaxies spin, and they spin way too fast. Add up all the stars, all the gas, everything glowing that we can actually see, and there's nowhere near enough gravity to hold a galaxy together at those speeds. By the visible math, galaxies should have flung themselves apart billions of years ago, stars scattering into the dark like sparks off a spinning wheel. But they don't. Something is holding them. Something with a huge gravitational grip that gives off no light at all. We call it dark matter, and the numbers are staggering. For every kilogram of normal stuff, stars, planets, people, this entire visible universe, there are roughly 5 kilograms of this invisible material. It outweighs everything we can see 5 to 1. We have never held a piece of it. We only know it's there because without it, galaxies make no sense. Picture every galaxy as a glittering city of stars sitting inside a giant invisible balloon of mass. And that balloon is the only thing stopping the city from tearing itself apart. For decades, that was the rule with no exceptions. Every galaxy we ever measured came wrapped in its invisible balloon. And then, in 2018, one galaxy showed up without one. A team led by Yale astronomer Pieter van Dokkum was studying faint, puffy galaxies, the kind so thin and spread out you can literally see distant galaxies straight through them, like cosmic tissue paper. Astronomers nicknamed them ghost galaxies. One of them, saddled with a deeply unglamorous name, NGC 1052, DF2, was about to cause chaos. To weigh a galaxy, you watch how fast things whip around inside it. Faster orbits mean more hidden gravity, which means more dark matter. So they tracked the bright clusters of stars swarming around DF2, fully expecting the usual too fast, dark matter-driven speeds. Instead, the clusters were practically strolling, lazy, calm. When they ran the numbers, the answer was almost heretical. The galaxy's motion could be explained by its visible stars alone. No invisible balloon required. For the first time ever, we were staring at a galaxy with little to no dark matter. And a year later, the same team found a second one, DF4, a near twin. Suddenly, it wasn't a fluke. It was a category. Now, quick, your gut is probably saying, so dark matter isn't real, they just proved it doesn't exist. It feels like the obvious conclusion. Hold that thought hard, because the truth does the exact opposite of what your instinct is screaming, and it's the most beautiful part of this whole story. Here's the first puzzle. If galaxies form inside those invisible balloons of dark matter, if the balloon is the mold the galaxy gets poured into, then how do you get a galaxy with no balloon at all? It's like finding a river with no valley for it to have carved. That alone is a headache. But here's the part that flips everything. For years, some scientists have argued that dark matter isn't a substance at all. Their idea, called MOND, short for modified Newtonian dynamics, says there's no invisible stuff. Instead, gravity itself just behaves differently out at the faint edges of galaxies, pulling harder than our equations predict. In that view, the extra gravity isn't dark matter, it's a built-in feature of gravity, everywhere, always. And that is the trap. Because if the extra pull is a universal law of gravity, then every single galaxy must show it. You cannot switch off a law of physics. But DF2 doesn't show it. Its extra gravity is simply gone. And a thing that can be present in one galaxy and missing in another isn't a law. It's a substance. It's stuff. By showing up empty, this little ghost quietly argued that dark matter is a real, physical material a galaxy can actually lack, and dealt a serious blow to the idea that it was only gravity playing tricks. The exception didn't break the rule. It proved the rule was about a thing, not a law. Of course, a claim this big does not get a free pass. And this is where it turns into a genuine scientific street fight. Everything, the whole no dark matter conclusion, hangs on one number: how far away DF2 actually is. Distance is everything here, because a galaxy that's farther away has to be bigger and brighter to look the way it does, and that changes its mass, which changes whether it needs dark matter or not. Van Dokkum's team measured DF2 at about 65 million light-years. But another team, led by astronomer Ignacio Trujillo, came back swinging. They argued it was much closer, around 42 million light-years. And at that closer distance, the math flips. The galaxy would be smaller, fainter, and perfectly ordinary, dark matter and all. So astronomers spent years locked in a very polite, very brutal war of measurements, using the brightness of stars, the glow of star clusters, and even the faint grainy speckle of the galaxy's surface as cosmic measuring tapes. Slowly, more and more independent methods landed on the farther distance, and on the conclusion that yes, this ghostly galaxy really is missing its dark matter. The empty galaxy survived the fight, which leaves the biggest question of all: how on earth do you make one? And in 2022, Van Dokkum's team pitched an origin story worthy of a heist movie. It turns out DF2 and DF4 aren't loners. They sit along a long, nearly straight trail of around 7 to 11 faint galaxies, lined up like beads on a string. The theory goes like this. About 8 billion years ago, two ordinary galaxies slammed into each other at tremendous speed. Now remember, dark matter barely interacts with anything. It just glides through. So in the crash, the invisible dark matter of both galaxies sailed straight on through and kept going, while the normal gas smashed together, compressed, and got left behind in the wreck. That shocked, stranded gas then collapsed into a whole row of brand new galaxies. Galaxies born from the debris, made almost entirely of normal matter, with their dark matter stripped clean away in the collision. In other words, DF2 isn't a galaxy that mysteriously forgot its dark matter. It's cosmic shrapnel, the leftover splatter of an ancient hit-and-run, still coasting apart across the sky. So sit with the beautiful irony of it. We went looking at a galaxy that, by all our rules, shouldn't be able to exist, a city of stars with no invisible balloon to hold it, no scaffold, no skeleton. And instead of breaking physics, it did something better. By being stripped naked, by having its invisible glue torn clean away, it let us see the outline of that glue for the very first time. You can only notice something is missing if it was real to begin with. The ghost galaxy didn't disprove dark matter. It's the fingerprint dark matter left behind when it walked out the door. So no, that galaxy 65 million light-years away isn't an error in the universe. It's the exception that proves everything else is hiding a secret. Every other galaxy you will ever see, including the one you're sitting in right now, is wrapped in 5 times its own weight of something invisible, something we still can't catch, name, or explain. And we only truly noticed it the day we found the one galaxy brave enough to show up without it. A galaxy that, by the laws of physics we trust, should not be able to hold itself together, and yet quietly, impossibly, still does.